আমাদের শেয়ার করুন তো আমাদের ব্ল্যাক আছে শেয়ার করুন শেয়ার করুন করেছেন এবার okay, you just try question 1 to 5 and after that you do serially from 32 1 2 3 4 5 and then serially from 32. Yes, good evening all of you. Okay, yeah, so good evening all of you. In today's session, we are going to try and complete whatever is there in indefinite integration. So hopefully today will be the last session on indefinite integration. Okay. No, we will have regular Monday classes. The answer to your first question is that we will continue to have regular Monday classes in spite of the mock test, because I think I mentioned that the mock test in one shot I will be giving all 5 papers to each of you, and you will have time till the end of the month to complete those papers. So that is the answer to the first question. The answer to the second question is that the answer to the second question is that I consciously don't write very big, but you are right, I should be writing bigger. So I'll do one thing, you just keep prompting me. I think that will be better. I have no problem with that, because consciously I write like this only, but this is a little small, I guess. So if you just prompt me, I'll start writing bigger. I think that's the best way to go about it. So I'll do one thing, since the size is an issue, I'll just read out whatever I have written. So basically, if you recall that, yeah, definitely, please do that, definitely, you should remind me. So what I'll do is that I'll just tell you, today we are going to do the substitution formulas, the the algebraic substitution formulas. So previously we have done substitution formulas of trigonometry, like integral tan, integral cot, integral cosec, integral sec, like that. But now we will be doing substitution formulas of algebra. So the first formula is dx by x square plus a square. So the answer will be 1 by a tan inverse of x by a. Right? Dx by x square plus a square 1 by a tan inverse of x by a. This is the formula, right? I'm just reading it loudly so that in case there is an issue with the size of the handwriting, you can just listen to me and note it down. Integration dx by x square minus a square is 1 by 2a log modulus of x minus a by x plus a. But for this formula, x has to be greater than a. X has to be greater than a. And the other one is similar looking. It is dx by a square minus x square. It is 1 by 2a log mod a plus x by minus x. Over here, x has to be lesser than a. So in this, x is greater than a, in this, x is lesser than a. Then integration dx by root over x square plus minus a square. In this, the answer is log x plus root over x square plus minus a square. So this is the integration, this is the answer. Number 5, dx by root a square minus x square is sin inverse x by a. Number 6, dx by root over a square plus x square is log x plus root over x square plus a square. So these are the 6 algebraic substitution formulas, right? Algebraic substitution formulas. Okay. Okay, integration dx by L1 to the power n. Suppose you are doing integration of dx by L1 to the power n, then you put L1 equal to z. Suppose you do integration dx by L1 to the power n, you put L1 equal to z, right? I don't want to give any example of this, just remember it like this. L1 stands for linear, anything linear. So dx by linear to the power n, just put the linear expression equal to z. Then integration dx by q1, so you have to put q1 is plus minus a square plus minus L1 square. So that means if you have dx by some quadratic, then you will have to write the quadratic in the method known as completing the square. So just remember, if you have dx by anything linear to the power n, then the linear has to be put equal to z. If it is dx by quadratic, then you have to write the quadratic in the form of completing the square. Okay, next we have partial fractions. Okay, we have partial fractions. So number one, so suppose you have numerator divided by quadratic, which is a product of linear. Partial fractions means what? That the denominator will be written in the form of combination of some terms, and you will have to separate the integral into different fractions. So if you have numerator like some polynomial n divided by quadratic, which is a product of two linear L1 and L2, so n by q1, so I can just call it q actually. So n by q, q is L1 into L2, and degree of the numerator is less than equal to 1. So the partial fraction for this will be n by q, that is n by L1 L2, that is a by L1 plus b by L2. So this type of splitting, n by L1 L2 is a by L1 plus b by L2, where a and b both are constant. So this type of splitting, n by L1 L2 is a by L1 plus b by L2, where a and b both are constant. So this type of splitting, this technique is called partial fractions. So in partial fractions, the first method is that numerator by quadratic denominator, like numerator by product of two linear, and the degree of the numerator will be either linear or constant, right? So this is partial fractions technique number one. Right, so this is partial fractions technique number one. Then we come to partial fractions technique number two. So suppose numerator divided by linear into quadratic, but the quadratic cannot be factorized. So there is something in the numerator divided by linear into quadratic, but the quadratic cannot be factorized, and the degree of the numerator is less than equal to 2. So n by LQ is a by L plus bx plus c by q. So n will be aq plus bx plus c into L, and then you have to solve. So here what is happening, that you have numerator by something linear into something quadratic, and this quadratic cannot be factorized, and the degree of the numerator will be equal to 2 or less than 2. So numerator by linear into quadratic is a by linear plus bx plus c by quadratic. Then you take a LCM throughout. After taking a LCM throughout, you just need to solve this and you will get the answer of you'll have to find the answer of ABC, and you'll have to put the answer of ABC here. See, at present what we are doing in partial fraction, we are just discussing only the method. We are not discussing particular sums, just the broad method. So this is method number 1, this is method number 2. Method number 3. Numerator by linear square into quadratic, so the quadratic cannot be factorized, and secondly the degree of the numerator is less than equal to 3. So So when you have numerator by linear square into quadratic and degree of the numerator less than equal to 3, so the partial fraction will be a by linear plus b by linear square plus cx by d by quadratic. Okay, number 4, numerator by linear into quadratic square. So number 4, numerator by linear into quadratic square. So and the quadratic cannot be factorized. So degree of the numerator less than equal to 4. So numerator by linear into quadratic square is a by linear plus bx plus c by quadratic plus dx plus e by quadratic square. So this is the method. Okay. So before I continue, I'll just quickly summarize the four types of partial fractions again. So number one, numerator by quadratic, where quadratic is product of two linear. So L1 into L2, and the degree of the numerator is less than equal to 1. So numerator by quadratic is numerator by L1 L2, that is a by L1 plus b by L2, where a and b both are equal to constant. Then numerator by linear into quadratic, so the quadratic cannot be factorized, and degree of numerator less than equal to 2. So numerator by linear into quadratic, you have to say a by linear plus bx plus c by quadratic, and then you will get this, right? So what I mean to say is that in each of these, this is the method. Eventually the answer will only come when you solve a and b. That solving how to do, we'll just see one or two examples. Then numerator by linear square into quadratic, so the quadratic cannot be factorized, and the degree of the numerator is less than equal to 3. So numerator by linear square into quadratic, a by l plus b by l square plus cx plus d by quadratic. And and of course, as usual, you have to proceed and find ABCD. Numerator by linear into quadratic square, the quadratic cannot be factorized and degree of numerator is less than equal to 4. So numerator by linear into quadratic square is a by l plus bx plus c by q plus dx plus e by q square, and then you have to solve ABCD, you will get the answer. So these are the four different types of partial fractions. Okay. Now, suppose you have some integral numerator by denominator dx, and degree of numerator is greater than equal to degree of denominator. So you will have to write the numerator as capital A into denominator plus capital B into d by dx of denominator plus polynomial n1 whose degree will be lesser than denominator. Once again, suppose if you have numerator by denominator, but degree of numerator is more than equal to degree of denominator, then you will have to write numerator as capital A into denominator plus capital B into d by dx of denominator plus n1, where degree of n1 will be lesser than the denominator. So after that, this will be the integration. So a into x, so b log d plus integral n1 dx by d. So integral capital A dx is ax, integral capital B into d by d is b log d, and integral n1 by d, this one you can easily do. This one you can easily do like number 1, right? So this more or less completes Okay, this more or less completes the all types of partial fractions, right? So once again, integral numerator by quadratic, which is product of two linear, you write it as a by L1 plus b by L2, and a and b both are constant, you solve for a and b. Integral numerator by linear into quadratic, but quadratic cannot be factorized and degree of numerator less than equal to 2. So n by LQ is a by linear plus bx plus c by quadratic. You write it like this. N by linear square into quadratic, quadratic cannot be factorized, degree of numerator less than equal to 3. So n by linear square into quadratic, a by L plus b by L square plus x plus d by q. Integral numerator by L into quadratic square. So a by L plus bx plus c by quadratic plus bx plus c by quadratic square. And numerator by denominator, where numerator has more degree than denominator. So you write numerator as a into denominator plus b into dx of denominator plus n1. And if you do that, then this will be the answer. So these are the complete 5 types of partial fractions. So suppose you have integration x squared plus x plus 3 by x minus 2 into x plus 1. Suppose you have this integration. So the numerator will be x square minus x minus 2 plus 2x plus 5. Denominator will be x square minus x minus 2. So 1 plus 2x plus 5 by x minus 2 into x plus 1, the whole thing dx. So in this sum, the numerator denominator have the same degree. So we will have to begin by writing a 1 plus, and the rest of the sum we have to do it like type 1, right? Then one example of number 2, numerator by linear quadratic. So dx by x minus 1 into 1 plus x square. This is an example. Then look at type 3, numerator by linear square into quadratic. So this type 3, I can give you one example like this. So 3x plus 1 by x minus 1 whole cube into x plus 1. So a by x minus 1 plus b by x minus 1 whole square. C by x minus 1 whole cube plus d by x plus 1. So 3x plus 1 by x minus 1 whole cube into x plus 1. A by x minus 1 plus b by x minus 1 whole square plus c by x minus 1 whole cube plus d by x plus 1. So this is an example. Okay, so we have seen a couple of examples, like I can give you more examples, but I think we have discussed all the types. Okay, I have given you a couple of examples and I have told you all the types of partial fractions. So I have given one example here, one example here, one example here, and I have told you all the types of partial fractions. Now you can also have a question which is not presented as a partial fractions questions, but it can be converted into a partial fraction question. So let's have a look at one such. So integration dx by sin x into 3 plus 2 cos x. This is the question. Integration dx by sin x into 3 plus 2 cos x. So this is integration sin x by sin square x. So integration sin x by sin square x into 3 plus 2 cos x. So this is coming sin x by 1 minus cos square x into 3 plus 2 cos x. Sin x by 1 minus cos square x into 3 plus 2 cos x. So you can convert this into partial fraction by taking cos x equal to y. So this is what I was telling you, that you may get a sum which is not presented as a partial fraction sum, but you can convert it into a partial fraction sum. So by multiplying above and below with sin, so sin x by 1 minus cos square x into 3 plus 2 cos x. So if I take cos x equal to y, then it will become, 3 linear factors in the denominator. So that way we can do the sum. Now suppose if you have a question in which both numerator and denominator are functions of x square. So suppose if I have a question like this, integration dx by 1 plus x to the power 4. So numerator there is nothing, denominator is a function of x square. So half 1 plus x square plus 1 minus x square by 1 plus x to the power 4. So this will become half x square plus 1 by x to the power 4 plus 1 plus half 1 minus x square by x to the power 4 plus 1. Okay, so I'll repeat again. Suppose both the numerator and denominator is fully a function of x square. Then you write, suppose this is a sum, you write it like this, split it like this. After that, So half 1 plus x square plus 1 minus x square by 1 plus x to the power 4. So half x square plus 1 by x to the power 4 plus 1 plus half 1 minus x square by x to the power 4 plus 1. So half 1 plus 1 by x square plus 1 by x square plus half 1 by x square minus 1 by x square plus 1 by x square. Okay. Then for this one, you have to put x minus 1 by x as y, and for that one, you have to put x plus 1 by x as p, right? In this one, to get this numerator, you have to put x minus 1 by x as y, and here to get the numerator, you have to put x plus 1 by x as p. So if you put x minus 1 by x as y, then 1 plus 1 by x squared dx is dy. So integration dy by y square plus 2. And if you put x plus 1 by x as p, then 1 minus 1 by x squared dx is dp. So dp by p square minus 2. So 1 by 2 root 2 tan inverse y by root 2, and this will be minus 1 by 4 root 2 log p minus root 2 by p plus root 2, right? So finally I am going to get 1 by 2 root 2 tan inverse x minus 1 by x by root 2 minus 1 by
আমার এক্সপিরিয়েন্স ছিল আমার ইনস্টাগ্রামে একটা ফেক অ্যাকাউন্ট আছে তানিষ্কা জ্যাকোবা ভেরি চাইল্ডিশ লাভ চকলেটস প্লিজ ফলো ব্যাক করে কোনো কিছু পোস্ট করেনি হার্মফুল, এবার আমার স্কুল থেকে কেউ একটা করেছে।
Okay, all of you, the video was buffering. Actually, what happens is that in the live streaming there is a Yeah, it's working fine now. Yeah. So integration dx by 1 plus x to the power 4. So half of 1 plus x square plus 1 minus x square plus 1 plus x to the power 4. So half of x square plus 1 by x to the power 4 plus 1 plus half of 1 minus x square by x to the power 4 plus 1. So half of, you divide above and below by x square. So 1 plus 1 by x square plus 1 by x square. Similarly here half of 1 by x square minus 1 by x square plus 1 by x square. And here you take x minus 1 by x, here you take x plus 1 by x as p. So 1 plus 1 by x square dx is dy and 1 minus 1 by x square dx is dt. So half dy by y square plus 2 minus half dv by p square minus 2. So 1 by 2 root 2 tan inverse y by root 2 minus 1 by 4 root 2 log p minus root 2 by p plus root 2. So 1 by 2 root 2 tan inverse x minus 1 by x by root 2 minus 1 by 4 root 2 log x plus 1 by x minus root 2 by x plus 1 by x plus root 2. So this is one important type of sum. Okay, so if you have dx by a plus b cos x, it will be dx by a plus b 1 minus tan square x by 2 by 1 plus tan square x by 2. Dx by a plus b into 2 tan x by 2 by 1 plus tan square x by 2. So you will have to do this type of sums by putting tan x by 2 equal to y. Suppose you have integral sin x by sin x minus cos x. So you will have to write it like this. So half integral sin x plus cos x plus sin x minus cos x by sin x minus cos x dx. So when denominator is a linear of sin and cos, you have to do like this. When numerator denominator both are linear of sin and cos, you have to do it like this. Then then integration 3 plus 2 cos x plus sin x by 6 plus 3 cos x plus 4 sin x dx. So regarding this one, so 3 plus 2 cos x plus sin x is a into d by dx of 6 plus 3 cos x plus 4 sin x plus b into 6 plus 3 cos x plus 4 sin x plus c. You have to do it like this. If you have a sum like this dx by x minus alpha into beta minus x, then you will have to do the sum by putting x equal to alpha cos square theta plus beta sin square theta. If you have integral dx by root over x minus alpha into beta minus x, you have to put x is alpha cos square theta plus beta sin square theta, and then do the sum. Okay, some important techniques are there. Dx by root over linear. So you have to put linear equal to z. Dx by root over quadratic. You have to put quadratic is plus minus a square plus minus linear square. So integral linear dx by root quadratic. So linear will be a into d by dq dx of q plus b. Integral quadratic by root quadratic. Then q2 is the top, so q2 is a into q1 plus b into dq1 by dx plus c. Dx by linear root linear, just put root linear equal to y. Dx by linear root quadratic, you put linear equal to 1 by y. Dx by quadratic root linear, again you put root linear equal to y. dx by q2 root q1 you put root over q1 by q2 equal to y. So these are some important techniques. So dx by root linear, you put linear equal to y or z. Dx by root quadratic, you put quadratic is plus minus is, that means completing the square. Linear by root quadratic, linear is a into dq by dx plus b. Quadratic by root quadratic, the top is a into bottom plus b into dq by dx plus c. Dx by linear root linear, put root linear y. Dx by linear root quadratic, put linear as 1 by y. Dx by quadratic root linear, put root linear as y. And dx by quadratic root quadratic, that is q2 root q1, you put root over q1 by q2 as y. So these are some important techniques. So integration 2x plus 3 by root 1 plus x square is an example of this. This question is an example, root over 2x plus 3 by root 1 plus x square. Just knock around the then dx by quadratic root linear is an example, 3 plus x square root 1 plus x. Then linear root quadratic, this is an example, dx by 1 minus x into root 1 plus x square. Then integral e to the power x by 1 plus e to the power 2x into root over 1 minus e to the power 2x. This is an example of quadratic root quadratic. Okay, so we have we have covered all the important types of questions, whether it is partial fractions, whether it is rational fractions. Rational fractions means the beginning we did linear to the power n, those questions, and we have covered important techniques of irrational fractions also. So we have more or less completed indefinite integration, and the next day we will start definite integral. We'll do definite integral the next day. So this session I am concluding here, right? Okay, bye all of you. I'll end the meeting. Thank you.